So let me tell you about the eye movements. So we had 176 people watching it. So we had 87 people in every condition, in both conditions. Okay, they watched the clip while their eyes were tracked, and at the end we asked them some questions like, what do you think will happen next? Okay, and our key question was, will the attentional synchrony eliminate the effects of comprehension on eye movements? And so the measures we used, we had the inference. So did they mention the guy falling on the circus tent, yes or no? And so when we asked them what will happen next, in the context condition, 91% of the people said the guy's going to fall in the circus tent. They made the inference. But in the no context condition, only 71% did. So that's a pretty big difference. Okay. And then what that enabled us to do is we could divide our eye movement data, this EM means eye movement, by whether they did or they did not make the inference. And then we also measured attentional synchrony. So we did that with eye movement similarity. Okay, so our hypotheses that we compared for attentional synchrony, we had two alternative hypotheses, and actually, well, we had the tyranny of film hypothesis that said there's no differences in eye movements due to comprehension differences. Because everybody's looking at the same place at the same time, their eye movements cannot be different even if they have different understanding. But then we had the event model hypothesis, and we actually had two alternatives of this. Okay? So the event model hypothesis says your event model will influence your eye movements. But it could do that in two different ways. If you have a better event model, then you could pay attention to important information. And if you do that, then you'll have more attentional synchrony. So people who have a better understanding will look in the same place because they're looking at the important stuff. But alternatively, if you have a worse event model, you might pay attention to very visually salient things, like things that are moving, things that are brighter, things that are more colorful. Then maybe people will just look at those, even though they don't understand the story, but they'll just look at big, bright, moving things. Okay? In which case, they might have more attentional synchrony. Okay? Just because they don't understand, they're just looking at stuff. Okay? So it could go either way. All right, so let's look at global attentional synchrony. So I'm going to show you the three conditions. We have no context, and they did not draw the inference. They did not say that the guy's going to fall in the circus tent. And then we have no context, but they did draw the inference. Okay? So they didn't have the context, like you guys didn't have the context, but most of you drew the inference. Okay? So that would be this group. And then we have the context group that did draw the inference. And that's almost all of them. Okay? So I'm going to show you, these colors are the colors that you see here, and the little circles, that's where people are looking. Okay? So brighter color means more people looking. All right? And these are, you can see lots and lots of little circles. Okay, that's where the people were looking at that time. And so, oh, there we go. All right. So what do you think? Do they look the same or different? Globally, they're very similar. Yeah? They're pretty much all around the same places. Okay? They're pretty much looking at the same things at the same time. Okay? So this would be support for the tyranny of film. Even though they have different understandings, for example, these people did not draw the inference, and these people did draw the inference. And yet they're looking at the same places at the same time. However, if we do a much more detailed analysis, we do find some differences, small differences. Okay? So here we're going to look at the attentional synchrony, the gaze similarity, or eye movement similarity, on a frame-by-frame basis. So this is all the frames in that 12-second shot. Each frame has its own analysis, okay? And here what we have is the no context who did not draw the inference, the no context who did draw the inference. Here's the context group in green who did draw the inference. And then this is the context group shuffled. The shuffled means we mixed it all up and we wanted to find what is the random chance level of gaze similarity when you mix them all up. Okay? So that will tell us like what is the bottom line, the minimum amount of gaze similarity. Okay? And so this is the minimum amount of gaze similarity. Okay? And the key thing was in shot 4. Shot 4 is the beginning of the cross-cutting sequence. It's the first shot where they see the circus tent. Okay? And they have to try to understand, why am I seeing a circus tent? And some people, in the context condition especially, as soon as they saw the circus tent and we asked them to think aloud, they said, the guy's going to fall in the circus tent. Okay? But not so many people did that in the no context condition. Half as many. Okay? This is shot 4. And notice, here's the green, and this is higher than the red and the blue. Okay? So these are the context group who made the inference. And they have higher gaze similarity. So that was our hypothesis that the mental model, if you had a better understanding, you'll look at the important things and you will look at the same important things, so you will have higher gaze similarity. And if we look here, you can see this is the context group that drew the inference. This is smaller than this. This is a little bit more spread out. That's the difference. Okay? So this is a real significant, statistically significant difference. On the other hand, it is small. Okay? So, from this experimental case study, what we can conclude is we have strong attentional synchrony in a Hollywood film, and it can easily hide large differences in understanding. So we had big differences in understanding between the people who knew that the guy is going to fall in the circus tent and those who did not. But we're only finding very small differences in eye movements. And this is consistent with the tyranny of film hypothesis. Okay? On the other hand, we are finding these subtle differences in eye movements based on understanding. They are real. We are finding real differences, but they're small and subtle. Okay? And so that's some evidence for the event model having an impact on attention. Okay. So this led us to raise a question. Can we increase the effect of the event model on eye movements? Okay? And so we thought, if we want to increase the effect of the event model, we need to decrease the attentional synchrony that is caused by the movie stimulus. Okay? And the Moonraker clip had a lot of cuts. It had 6 shots in 12 seconds. So basically, 1 cut every 2 seconds. Okay? And we know that there is actually increased attentional synchrony at cuts. And let me quickly go back here and show you that. These red dotted lines are all of the cuts. Okay? And you notice that after the cut, the gaze similarity goes down and then it jumps up. And then here, down, jumps up. And then a little jump up. Here we have it jumps up. And then down, jumps up. The reason that happens is because anytime there's a cut, people immediately, wherever their eye is, they send their eye to the middle of the screen. That's why you get an increase in attentional synchrony when there's a cut. Okay? But that doesn't mean that they're really understanding it. It's just whenever everything on the screen changes, they send their eyes to the middle of the screen. All right, so it had many cuts, and this increased the attentional synchrony at the cuts. Okay? Also, in the Moonraker clip, we always had one thing to look at. Usually, it's either the falling man or it's the circus tent. And it's pretty much in the middle of the screen. Okay? So that would also increase attentional synchrony because there's only one thing to look at. Okay? So what we need is a film clip with no cuts, just one shot, and many different things to look at. Okay? Then we can have less attentional synchrony, so maybe less tyranny of film, and then more effect of the event model. And so we picked a very famous film shot from Touch of Evil by Orson Welles. Okay? So it's a very famous shot in which it's a 3-minute and 30-second shot. Okay? No cuts.